Hello everyone and welcome to another part of the Galaga SDL tutorial videos, and in this video we're going to start on the enemy diving. So after the last video I wasn't really happy with the way some of the variables or the functions are called because it wasn't descriptive enough. So at the beginning of this video we're just going to start by changing a few of these things so that the functions are a bit cleaner and easier to understand. So the first thing that we're going to do is go to our enemy.h. And in here, the most confusing part was the target position because it doesn't really describe what we're doing with it. So we're going to start off by just taking it out altogether. So target position will be taken out. And next up, we are going to change a few of the functions. For example, the fly in target position, that we don't really need because the fly in target position is the position inside the formation. So we can split that off to two things, because this is the local formation position and the flying target position was just taking the formation's local position and adding the formation's position, S formation's position to it. So what we can do is change these two functions to be the world formation position and the local formation position. So what we can do is cut that and paste it here. So over here we will change this one to the world formation position. And the formation position can be the local formation position, and that will make it a lot more descriptive. So this is the position of the object of the enemy within the formation itself, and then this is the world position overall of that local position of the enemy within the formation. So now we can go to our enemy.cpp. So enemy.cpp, there we go. Okay, so like we said, this one is taking the S formation and adding the target position, which should have been the local formation position. So what we can do is change this one. So the fly in target position can be our world formation position. And this one will take the S formation position and add to it the local formation position, because the local formation position differs from one enemy to another. So that one will be virtual because we have it pure virtual right here and setting it specifically for each enemy, and the world position can always be the same. So now it's going to complain that our flying target position is not being is undefined. So over here, once the fly-in is complete, what we want to do is set our world position to the world formation position, and that's what we're going to change it to. So world formation position for this one, and then if we keep going down, so what we're doing here is going towards our world formation position from where we are, so we can join the formation. So we can change the fly in target position to world formation position as well. And then if we keep going down, so that was in handle fly in state. And the handle formation state, we're setting the formation position to be our local position. In here, what we want to do is set our position to the local position, because we're inside the formation now. The parent is S formation, so we will need to set our position to our local position. So it will be local formation position. And these are the changes that we're going to need to have in here. So now it's a lot more descriptive. We're using the local formation position when we're dealing inside the formation, and we're using the world formation position when we're outside the formation trying to get into formation. Okay, so the next thing that we need to do now is a way to join the formation, because right now when in flying complete we are joining the formation, but after a dive we also need to join the formation. So we're going to repeat these lines, and we don't need to do that. So what we can do is to create a new function, so right above these two, and we can call this one void join formation. And all that would do is to, so if we go back here again in enemy.cpp, and we can declare join formation right above our where are we declaring the world formation position? Right here. So we can put it right here, and that can be void enemy join formation. And what this will do is do everything in the flying complete. So we can cut everything in flying complete and add it to join formation. And now for our flying complete, we can set specific, set an F statement so that we join the formation if it's not a challenge stage. If it is a challenge stage, we set our current state to null. So now flying complete, what it will say is if M current state, or if M challenge stage. So if we're in the challenge stage, what we want to do is set our M current state to dead. Otherwise, so if this is not a challenge stage, we want to join the formation because our fly-in is just completed. So join formation. And that will be the change that we need to do in here. So now what we can do is to move on to the rest of the things that we need to add. The first thing will be our rendering, because our rendering right now is just based off of the current state equals formation. So if our current state is formation state, we're having the animation run for the formation state. Otherwise, we're just rendering textures at 0. But we need to be a bit more specific than that. So we're going to have the same setup for the update to be the same setup for the render as well. So instead of handle though, all these would be render. Over here, we can say virtual. So right underneath our handle states in enemy.h, we can add the render functions that are specific to each state. So virtual void render fly-in state, virtual void render formation state. Oh, no space there. So render formation state, virtual void render dive state, and virtual void render dead state. And these will be all our 4 states. These two, the render dive state can be equal 0 because this will be enemy specific, and the render dead state will be equal to 0 because that will be enemy specific as well. So these two are done. We can move on to our overall function. So instead of handle states, will be render states. So void render states, and these will be the 4 or 5 functions that we need in here for now. So we can go back to our enemy.cpp and start creating these states. So over here, right underneath handle states, we can start by creating our void enemy render fly-in state. So when we're flying in, for now we're rendering textures at 0. So we can say m textures at 0 render. And then later on we can add the logic for the flying animation. But since we have this function for now, we can keep it as it is. And then void enemy render formation state. And we already have logic for that, which is this one. So we can cut this and paste it right here, and that will be our formation state rendering. And then the other two, they're pure virtual, so we don't need to implement these two. So the last one will be our render states. So over here, we can say void enemy render states, and then switch our current state. So m current state case fly in. So in fly in, we will be rendering fly in state, case formation break, we will render formation state, case dive or dive, we will render our dive state. So render dive state, and then case dead, we will render dead state, and then break. Okay, so now that we have all this here, we don't need this stuff inside render, so we can delete that, and all we can say is just render states. So just like update, and that will be it. So if we want specific rendering for an enemy, we can just override one of these and change it inside that class. Okay, so these are most of the changes that we need for the enemy. The last change that we need to do is to specify what enemy type it is. So inside enemy.h, we can add another enum. We'll call this one types, and this one will be butterfly, wasp, and boss. And that way we can, from the level, because we're using an enemy pointer array for all the enemies together, we're not using a specific array for each one. What we can do is to specify what type of enemy. So inside butterfly.cpp, for example, we can set our type to butterfly. So since we need to set each type, we need a variable for that. So right above index here, we can say we can create a types variable called mtype, and that will be set inside each different enemy. So finally, we can go to our public functions, and we need two functions in here. Underneath current state, we can have types, type, and that will just return our type, and void dive, and this will tell the enemy to dive. So that will be it for our enemy.h. These are all the changes that we need to do in here. So in enemy.cpp, we need to implement these functions that we just created. So type and dive. So we'll go down underneath current state and have enemy types, enemy type, and this will just return mtype, and then void enemy dive. And the reason why dive is not virtual is because for this one we just have it so that we are going to set our current state to dive. We are going to set a few variables in here, but then the rest is going to be handled by the enemy itself. So in our dive function, we are going to set our parent to null, for example, because in formation, while the enemy is in formation, S formation is the parent. So we need to break away from the parent. So parent is null. Our current state is going to be equal to dive. Did we have our starting position for the dive? We don't. So inside enemy.h, right underneath challenge stage, we need to set a starting position for our dive. And that's because inside the formation, the enemies are moving over time. So our dive path will depend on where the enemy is within that formation. So what we can have is a vector2, m dive start position. And this will be the world position of the enemy as soon as the dive starts. So in enemy.cpp, we can say the dive start position is going to be equal to our world position. So we can just call the position function. And then we will set our current waypoint to 1. That's because we want to start following the dive path, and we're already using the current waypoint for the fly-in, but we're not going to be flying in again, so that we can just reuse the current waypoint for our dive path instead. And that will pretty much be all the changes that we need in the enemy class. So this will be it for that. We can now move on to our Wasp class, because that's what we're going to implement the diving for in this video. So we can go to our wasp.h. And in here, what we want to do is to first have a path for our dive. And that path will be shared among all the wasps in the game. So just like we did here for our paths for the enemy, we had a static two-dimensional vector of vector2s for the paths. We can do the same thing for the wasps. So a static std vector of std vectors of vector2s, and we'll call this one sdive paths. So this will handle all the dive paths that we have for the wasps. Okay, so over here we still have a fly-in target position. And fly-in target position we actually don't need anymore, so we can just take that out. The formation position was our local formation position, so we can change that to local. And that's pretty much what we need for these changes. Now we need to add the rendering functions because we have him here as pure virtual, these two. So we need to add the render dive state and render dead state in the wasp.h. So underneath here we can say void render dive state and void render dead state. And these are the functions that we need to add. Now for the public functions, we need to create these paths. So we will add a static void create dive paths. And each enemy will have a create dive paths and a dive vector, a dive paths vector for that enemy. And these are going to be all the changes that we need for the wasp.h. Now we can move on to our wasp.cpp. So in wasp.cpp, we can start off by first initializing our static vector. So up here we can say std vector of std vectors vector2, and this one is called wasp s dive paths. So we have this here now. If not challenge stage, we can just remove that because we're not using the target position anymore. And underneath here for mtype, we can set it to wasp. And that will be it for the changes in our constructor. Now to create our paths. So void wasp create dive paths. Okay, so the main idea behind this function will be exactly the same as the enemy.cpp. So all the way up here in create paths, we're just creating a new path, a new Bezier path, adding a curve and pushing it back into the path vector. So this template will pretty much copy and paste it there, but we'll just type it in so that we can have the specific path for that enemy. So int current path is going to be equal to 0. So this is our first path. And then Bezier path pointer path is going to be equal to a new Bezier path. And then we'll delete the path at the end. Now what we want to do is add a single curve so that we can see what it looks like inside the game. So what we will do now is say that our path add curve, and the way that the wasps are diving in the game is that what they do is they start off from where they are in the formation, and if they're on the right side, they take a turn to the right side, and then they start diving downwards and to the left. So the first thing that we need to do is to do a semicircle towards the right side in our first path. We'll create two paths in this video, one for the enemies on the right side of the screen, which will be diving like this, and one on the left side of the screen, which will be diving in pretty much a mirrored path. So the first one we're going to create will be a path that will fly to for the enemies on the right side. So we'll add a curve. So the first curve that we need to add is the small semicircle so that it can turn around and face downwards. So add curve, and this will take a Bezier curve struct as well as the sample. Since it's a curve, we need the sampling to be a little high, so we'll set it to 15 for this. And then for the struct of the Bezier curve struct, we will add the 4 vector 2s. So vector 2, vector 2, vector 2, and vector 2. And for us to reuse this path for each enemy, we need to have the path as a local path within the enemy's local grid. So the start point for the path will be the enemy 0, 0, because this is the enemy's start position. So we can have our starting position as 0, 0. So 0.0f and 0.0f. The end position will be to the right of the enemy. So let's say 30 pixels to the right. So we'll have the end point, which is our last vector 2, as 30.0f, and the y can be 0.0f because it's straight to the right. Now for the control points, for the first point, it needs to be 0.0 f on the x, and the control point needs to be pointing upwards, because if I open up the curve editor here, as you can see, for a curved path to be this way, we just have to have our control points above our point that we're controlling. So 0.0 f on the x, and on the y can be negative, let's say 30.0 f, because in SDL, negative is upwards. So that's why this is negative. And then for the control point for the endpoint, so the endpoint is a 30, so for the x, the endpoint, the control point for it needs to be 30 as well. So 30.0 f. And we will move it up just as much as the control point for the start point. So it will be negative 30.0 f. And that's pretty much will be our first curve. And we can just keep this curve and then see what it looks like and then add to it once we are rendering that curve. So now we can say sdive paths dot pushback and std vector of vector 2's, and then path sample, and then we'll pass it in the vector 2 that we just created. So we'll say ampersand sdive paths at the current path. And this is pretty much going to be it. So this will be our setup for now. We haven't created the other path yet, and we haven't finished this one, but for now we're just going to use this one to render it so that we can see what it looks like and then start adding more and more curves to it. So now that we have this, we can move on to some of the changes that we have underneath here. The first change will be for the flying target position. We already took this out because we don't need access to the world formation position. It's already being set in enemy.cpp. So we can completely take the flying target position out. The path complete, what we're going to do is for now set it to enemy path complete, because we're not handling the diver wasps for now. Once we have the diver wasps, we're going to change that. Now, the flying complete can be changed a little bit. So instead of, so if it's a diver, set the current state to dead. Otherwise, we need to join the formation. So we can just say join formation instead. And that will be it for flying complete. Now to move on to our formation position, as we said earlier, this one will be our local formation position instead. So that takes care of that error. And finally, we can render the path that we just created. So over here in our handle, well, we actually need to add those. So void wasp render dive state and void wasp render dead state. So in our render dive state, what we want to do is just to render textures at 0 for now, because we don't have any animations yet. So textures at 0 render. And then we want to also render our path that we just created, so we see what it looks like. So over here we can say for int I equals 0, I is less than sdive paths at 0, and then we'll specify the dive path later on, dot size I++. But instead of dot size, we need dot size -1, because we're rendering each successive point as well. So once we are at sdive path -2, we also want to render sdive path -1 because it's a line. So over here we can do graphics, instance, draw a line, and this one will be our m dive start position dot x plus s dive paths at 0 and I dot x. So that's our start x position, and then our y position will be dive start position dot y plus s dive paths at 0 and I.y. So these are the first, our start x and start y. Our end x and end y will be I plus 1. So we can go over here and say that our next one will be m div start position dot x plus, oh, we forgot a comma here. So dot x plus s div paths at 0 and I plus 1 dot x. And finally, m div start position dot y plus s div paths at 0 and I plus 1 dot y. Okay, and that will be the line that we want to draw. Now the last thing that we need to draw is to, because right now we have our dive paths. So the only thing that's left is to send the enemy back to where it should be in the formation after the dive. So the last line that we need to draw will be a vector2 final position is going to be equal to the world formation position, because we need to go back to the formation. And then vector2 let's call this one path end position. So path end pause is going to be equal to m dive start position plus s dive paths at 0 and s dive paths at 0 dot size minus 1. So we're just getting the last point in the path. So the last, the last point in the path, and our final position is the formation position, so that we can draw a line between these two. And then graphics instance draw a line, and we just need to draw a line between these two. So the first one will be our path end position dot x and path end position dot y, and the end ones will be our final position dot x and the final position dot y. And that will be it. This should allow us to see our path that we just created. Now, there are some changes in the butterfly.h and the boss.h, quick changes that we need to make because we changed the fly in position. So we'll go to our butterfly.h. Instead of formation position, we'll change that to local. And we will add our void render dive state and void render dead state. So these are just quick changes that we need to make for now. And then in butterfly.cpp, we will remove the if not challenge stage altogether. We will set our m type to butterfly, and then the formation position will change to local formation position, and then we'll add the two rendering functions at the bottom. So void butterfly render dive state, they can be just empty. So void butterfly render dead state. There we go. And then the boss will be the same idea. So boss.h formation position will be local formation position, and then void render dive state and void render dead state. And then in boss.cpp, we will remove the challenge stage bit, and we'll say that m type is going to be equal to boss. Then the formation state will be local formation state instead, so that's fine. And then void render dive, or enemy, or boss actually, boss render dive state and void boss render dead state. So that will be it. I don't think I did for the butterfly. Oh, I did. Okay. So these are all the changes that we need to do for the boss and the butterfly, because we're not doing any behaviors for these two enemies yet. So now we can close these up. We don't need them anymore. And we can move on to creating that path, because create dive paths needs to be called at least once. So the best place to call it is when we're creating the enemy paths as well. So we will go to our play screen.cpp. So where is our play screen? And in the constructor of the play screen, we're calling enemy create paths. So we can call Wasp create dive paths as well. So that's all we need to do in the play screen. We're creating the dive paths, and we'll repeat the same process for the butterfly and the boss later on. So now we have our dive paths being created. We can go to the level and start diving these enemies. So we will move on to now level.h. So the first thing that we're going to need to do in level.h is to be able to handle the enemy diving. So we will go to our private functions. We have handle enemy formation and handle enemy spawning. So we can have void handle enemy diving. And that's the function that we're going to need in here. So let's go ahead and implement it. So in level.cpp, where is our level.cpp? We will go down to where our handle enemy formation is. And then underneath it, we can add our handle enemy diving. So in here, we can just set a key to start an enemy to dive. So void level handle enemy diving. So first, we need to check whether the formation is locked or not. And we actually don't have a way to get that back, because we're locking the formation, but we can't check whether the formation actually locked or not, because after the formation we call lock. So if we open up formation.cpp, after we call lock, it sets lock to true, but it waits until the offset counter is equal to 4 to actually lock the formation. So what we need to do is to add another function to the formation class. So in formation.h, right underneath lock, we can add a boolean called locked, and that will return true if the formation completely locked. So in formation.cpp, right underneath locked, we can say boolean formation locked, and that will return mlocked. So lock needs to be true for the formation to be truly locked, and the offset counter is going to be equal to 4. So if these two are true, then the formation is actually locked, and we can use that. So in level.cpp, we can say if mFormation is locked, we can handle the enemy diving. So if the input manager instance key pressed, so once we press down a key, SDL underscore scan code underscore, let's say V. So when we press the V key, we want the first wasp to dive. So in the original Galaga, the bottom wasps dove first, and after you killed them off, the top wasps started diving. So we'll start with that. Or actually, we're gonna start from all the way at the back. The outer wasps dove first, actually, and then the inner wasps dove after. So we'll start that. The way that we're setting it up is that as the wasps are added in, they're starting from the inside out. They're being placed from the inside out. So what we can do is loop through the array backwards and start the diving of the enemies from the end of the array. That way we'll make the outer wasps dive first and then the inner wasps after that. So for int I equals enemies dot size -1, I is more than or equal to 0, and then I minus minus. So we're starting from the end of the array and going back to 0. If enemies at I type is equal to enemy wasp, so if we encounter wasp and that enemy is in the formation state. So if m enemies at I, current state is equal to enemy formation. So if the current state is formation state, and if the enemy is a wasp, we need to start it to dive. So what we can say is enemies at I dive, and then break, because we don't want to keep looping through and make them all dive. So break out of the loop once we found the enemy to dive. And that will be it for handle diving. So we need to call this function. We'll go down here, and right underneath handle enemy formation, we'll handle enemy diving. And these will be the changes that we need to make. So we can go ahead and try to run this and see what happens. See if we caused any errors. Wow, I guess not. There we go. So we can start out by creating a few enemies, and then once they're in formation, we can check we can press V to make sure that they can't dive, because the formation is still locked, so that's good. Now we can spawn the rest of the enemies that we have. And there we go, the formation is locked, and we can press V. There we go. As you can see, it's going up right there, and then it's going back to where it should be in here. So this is working pretty well. Now we can expand onto this path to make it dive all the way down. Okay, this is working. So if we keep pressing V, each enemy, as you can see from the outer edges in, they're starting to dive one after the other. So this seems to be working pretty well. So now we can go over to wasp.cpp. Actually, maybe we can have the interpolation for the path, so we can follow the path. Now to make the enemies, the wasps, dive in, follow that path and go back to formation. And where we can do that is in wasp.cpp in our handle dive state. So the way we're going to handle our dive state is by following that path. So we can say int, or actually if the current waypoint is less than the dive paths, add 0 dot size, and then else. And you'll notice that this looks pretty familiar because it's pretty much the way that we're handling the fly-in, there we go, the fly-in state. So over here we can say that vector2, and this is where it differs a little bit. The waypoint position is going to be equal to, because our paths are local to the enemy's position, we need to offset this path by our start dive position. So what we can say in here is m dive start position plus s dive paths at 0 and the current waypoint. And that will offset it to our dive start position. Next up, vector2 distance is going to be equal to the waypoint position minus our world position. And then we're going to translate by dist.normalized multiplied by the timer delta time multiplied by our speed, so m speed. And this will be done in world space. So that will be it for this part. And then our rotation will be set to be our atan 2 of our dist.y and dist.x multiplied by rad2 degree plus 90.0f. So pretty much the same thing that we have in here. And then next up, if the waypoint, so m current waypoint. Oh, actually, we need to know now the distance between our waypoint position and our current position, because we just translated. So we are gonna say if the waypoint position minus our world position dot magnitude squared is less than the epsilon value that we created in enemy.h, then our current waypoint plus plus. And that's pretty much going to be it for this part. Next up is once the path is complete. When the path is complete, we need to fly back to our formation's world position. So we can say vector2 final position is going to be equal to the world formation position. And then vector2, actually, we don't even need the final position. We can remove that, and we can just say dist is going to be equal to our world formation position minus our world position. And that will be the distance that we need to cover. Next up is to translate along that normalized. So translate along dist.normalized multiplied by m timer delta time multiplied by our m speed, and this is in world space. And finally, the rotation is going to be equal to a tan 2 of dist.y and dist.x multiplied by rad underscore 2 underscore degrees plus 90.0f. So that's pretty much the same idea here. And finally, over here we can say if the dist dot magnitude squared is less than our epsilon value. So if it's equal to the epsilon value, that means we reached where the formation is again, so we need to rejoin the formation. So we can just say join formation. And that will be, these will be the changes that we need to make it follow the path and rejoin the formation again. So let's run it and see how it goes. Well, let's spawn all our enemies. There we go. And then started diving, and there we go. So as you can see, they dive to where they should go and then go back. So now we just need to expand the dive path, and then we pretty much have our diving paths for the wasps working. Okay, so the arc seems to be pretty small, so I'm gonna change it a little bit to, let's say, 60 or so. So let's double its size. So over here in our endpoint, instead of 30 on the X, we can put it to 60 on the X. And we're probably gonna need to change the control points Y a little bit. So instead of -30, we're gonna change it to -45. So let's see what that looks like. And like I said before, the Bezier curve stuff is a lot of trial and error, so you just need to check if it looks right or not, and if it doesn't look quite right, you can just change the look of the curve. So there we go. That looks pretty good. So it's going up. So now we just need to make it go down from there. So from there down towards where the player is. So let's add another curve. So we'll just copy and paste this curve. The start point will be our end point from the last curve. So we'll add it right here. And the control point for this one will be, well, we want it to look something like, so our second one will be somewhere down here, but we want this one to curve this way, and then for this one to be like this. So as you can see, this one needs to be pointed straight down. The control point for this point needs to be pointed straight down, and the control point for this point needs to be straight up so that it curves that way. Or actually, I think it first started off being something like, oh, these are very hard to control. I think what we want first is to make it, because in the path for the original wasps, what they did was they did a turn and then they came into a 90-degree turn first, and then they started going down. So we'll have something like this first. So this one is straight down and this one is straight to the right. And that's what we're going to do. So for 60, this is where we are right now from our last point, and we'll point this one straight down, the control point for it. So if it's straight down, we'll make it something like 80.0f. And then our second point will be somewhere to the left of that point. So over here, we'll make it something like, let's say, negative 200 from where we are. And it needs to be lower on the y. So let's say something like 200 on the y. Now we know that our control point needs to be straight to the right of it. So our control point on the x can be, or control point on the y can be exactly the same. So our control point can be 200 as well. And our x for the control point needs to be negative 200 and added, let's say 50. So it would be something like negative 150. So let's see what that looks like. And if we don't like the way it looks, we can change it and have a better curve. There we go. And okay, as you can see, it's not quite right, but that's pretty much the process that we go through, or that's the process I go through to get the right curve for the path. So now I'll just add the values that I already have from before, because I already figured out these points that I need for the path. But if the path that we come up with is not good enough, you can just go ahead and change it to whatever path that you want it to look like. But first, we also need to make the enemies on the left dive in the opposite direction. So this is what we're going to do. We're going to go here and create another path. So we're going to say the current path is going to be equal to 1, and that's in our create dive paths. So the current path is equal to 1. Our path is going to be equal to a new Bezier curve. And then all the way at the end, we can say delete path. What is it complaining about? Oh, a new Bezier path. Okay, so now all we need to do is to copy everything in here and paste it there. But what we need to do is to just flip all the x values. So 60 would be negative 60, 60 would be negative 60, and then 60 would be negative 60, 150 would be, negative 150 would be 150, and negative 200 would be 200 instead. And whenever the enemies are picking the path that they're going through, so in our handle dive state, we can over here say int current path is going to be equal to, we know that when we're setting down the enemies, we have 0, 1, 2, 3, 4, 5, 6, 7. So all the even numbered indices are on the left side and all the odd numbers on the right side. So when we're picking the path, we can say mindex modulus 2. And that will give us, for all the even sides, we'll get, the current path, so for this one, the current path is going to be modulus 2. We'll see how that works. And then take the current path and change all the zeros by it. So we have a 0 here. So these are pretty much all the paths that we need to cover. And then we'll do the same thing for the rendering. So this was handle dive state. Render dive state, we will go down here and put that right over here, the current path. And then the current path, instead of 0 here, that will be changed to current path for these two. So this one, current path, current path, current path, and current path. And then we'll change this one to current path and current path. So all the zeros we just changed to current path. So let's see now how that looks. Let's run it. And spawn all our enemies. There we go. And then once the formation is locked, we can start them diving. Oh, that's flipped. So we want these ones to be going this way and these ones to be going that way. So what we can do is to just flip the paths that we have. So we can cut these two and paste them here, and then cut those two and paste them there. So we just switch these two together so that our path at 0 is the one on the left side and our path at 1 is the one on the right side. So let's see how that goes. There we go. These are all our enemies. And there we go. So the ones on the right side are going this way and the ones on the left side are going that way. Now I'm just going to add all the values that I already have for the paths here. So that, because the videos are already getting pretty long, so I don't want to go through the entire trial and error process of finding a good path for the enemies. So over here I have -60, 0 and 80. For this one, I have 0.0f and 0.0f. And then for the control point, it's 150.0f. And then for this one, it's 100.0f for the endpoint. And for the control point, it's 150.0f. So that's pretty much it for the second curve. The third curve will be 100.0f and 150.0f. So just like what we have for the endpoint here, but the control point for this one will be 250.0f and 150.0f. And then the endpoint will be 350 and 200 for the endpoint. And the endpoint itself will be 350 and 350. So let's see, let's copy this and paste it here and flip all the values for the X. So this one is 60, this one is 60, this one is 60, this one is -100, and then this one is -100, -250, -350, and -350. So we're just flipping all the values for the X and see what that looks like. So let's spawn all the enemies. There we go. Okay, so there's only one thing left, is the last curve down here, but it seems to be working pretty well, I think. This over here seems a little odd. Maybe I missed something. So let's see what happened here. Oh, this one, right. So over here, this one is supposed to be -60.0f and -60.0f. So that was 0.0f instead. So we'll do the same thing here. So that will be 60.0f. And finally, the last one will be, so we'll copy this and paste it again. This one, the start point will be 350 and 350, just like the other one. And the control point for this one will be 350 and 575. And now for the control point for the endpoint will be 100 and 100. And the endpoint will be 350. So that's fine. For the 200, instead of 200, this one will be 575 as well. And that will be it for that. So we can copy this, paste it here, and flip all the x values. So this one will be positive 60, negative 100. This one will be positive 60 and positive 60. This one will be negative 100, negative 250, negative 350, negative 350, negative 350, negative, negative, and negative. Okay, now this should be the complete path for the Wasp. So let's see what that looks like. There we go. All our enemies are in. And now we can press V, and there we go. So they're following their complete dive paths. And as you can see, depending on where they are, they're following that path, and then going back to where they should be within the formation. Okay, and that should be it for these ones. The butterflies on the bosses should be a lot easier to do since we set up all the underlying code now to handle diving altogether. So all we need to do now is to just set up the same thing for these two to have their dive path vector and create their dive path. So I might make the bosses and the butterflies in just one video later on. But that will be it for this video. I really hope it helped. If you have any questions, suggestions, or feedback, please leave them below. Otherwise, thank you very much for watching, and I will see you in the next video.